panic. We're live. We're live.
We're here. Will I ever manage to do that 30 seconds in Hobby Corner in time? Nope. We'll
Panic.
randomly flash us before. Well, hello, everybody. Well, and we have a big side chat. We're loving the side chat today. Okay, right.
Double figures.
Double figures. Before we start, I'm Ette, and this is my hobby corner, a little wholesome content corner where we talk about hobbies. And we have a very special guest, one of my friends. This is, well, would you like to introduce yourself about what you prefer to be called and your pronoun?
Well, I'm Steve, he, him. Yep, I think most of you know me from Piplash and Friday nights and stuff, if those of you out there. So, yeah, Ette invited me on to have a chat about my hobby, so I said yes, and here we are.
Indeed. And your hobby, would you like to say it?
Yeah, I do. Well, I try to do astrophotography. So I'd like to take pictures of mostly nebula, but galaxies some as well. I do a couple of planets and a bit of lunar. But yeah, I like to take pictures of stuff that's up there. So yeah, those of you that are here from the sort of flat Earth side of things know that it's not possible what I do with a flat Earth. So yeah, it's fun. It keeps me out of trouble, and I enjoy doing it.
Sorry, I've been told that I'm making really nasty noises, and I don't know where my headphones are.
You could see a doctor about that.
Uh-oh. I don't know.
You're a little bit crackly, but
we do have technical difficulties right now. I apologize. I don't know where the headphones are, Tusk. I'm sorry.
Don't panic. Don't panic. If I could play an instrument, I'd do a little interlude, but I can't. That's why I do astrophotography.
Well, how about I mute while I try and get my headphones set up and dealt with properly, and while you give us a little introduction to what is astrophotography and how you got into it.
Okie dokes. Well, astrophotography is basically the taking of pictures of anything in the night sky. So anything from the moon to the planets to the sun, anything that's out in space. Astrophotography is taking a picture of it, and there are loads of different ways to do it. Some people just use a mobile phone. You can just use a mobile phone to take pictures of either through a telescope, or you can use everything up to special cameras and special telescopes that are designed specifically for taking pictures of galaxies and nebula and things like that. So so it's quite a wide-ranging hobby. Lots of people can get into it at different levels. And yeah, I got into it. I suppose I've had a telescope over 10 years, but I didn't start taking pictures until about 3 years ago. So I had a telescope that I used visually, as they would say, so just for looking at the planets and the moon and those sort of things. But you can't see a lot when you look at nebulas and galaxies. Visually through a telescope. You only get the best detail out of those when you take a picture. So that's why I wanted to start taking pictures.
Do you ever like to find what's it called? The star constellations, like Sagittarius and
they can be very useful to sort of to know where they are in the sky, especially when you're starting. When you're starting out, and you don't have all the magic computer kit that I've got, you need to be able to sort of find things in the sky yourself, and you need to know where things are, because everything's in a constellation. So there's a picture we might look at later called the Pac-Man Nebula, and that's in Cassiopeia, which is a W-shaped constellation in the north. So it's useful to know where the constellations are. But you don't have to. I don't know all of the constellations. That's why I would never say I'm an astronomer. I'm not an astronomer. I don't know all the constellations. I don't know all the phases of the stars and all the weird stuff, all the sort of astronomical stuff. I just like taking pictures. So yeah, I would always call myself an astrophotographer, not an astronomer. I'm not clever enough to be an astronomer. Oh, have we lost Ette? So I keep talking anyway. Tell you what I'll do is I'll pop up a share screen and pop up a picture of my first telescope while it's sorting things out. And window. So there we go. I think that hopefully will come up. And that's my first telescope that I bought 10 years or so ago. And it's a Newtonian. I'm just waiting to see whether it's going to come up. It's not coming up in StreamYard, is it? Nope.
There we are. It's here.
Oh, there we go. You got it. There we go. Now you can see it. So yeah, that's it's an. Oops, go back. There we go. So it's a Newtonian telescope, which means it's got a mirror at the bottom of it. So the mirror gathers the light and focuses the light down to an eye hole, or if you're doing visual, or down to the camera. So that's one of the types of telescope that is most commonly used. These are slightly bigger than the normal telescope. The other type of telescope, which is this is my first sort of proper imaging setup. I think you should be able to see that. Yeah. So that's a refractor. So you can see it's a long tube and it's got glass lenses in instead of a mirror. So those are the two main types of telescope. And Newtonian has a mirror at the bottom of it, and a refractor is the one that most people think of when they think of a telescope that has lenses, glass lenses in it.
That's cool.
And so, and the purple things you can see on the end there are cameras. So that's what I use to take the pictures. There's no cabling there. What we can do is we can have a look at that telescope in a minute. I can take it out and I can show you how I make an imaging setup. But a couple of the pictures that I've taken with those first two. With that first telescope, this is the simplest way to take a picture. So this was taken using a mobile phone.
Oh my God, that's amazing!
Through that first telescope. So you have to have a telescope to start with, but you don't need any fancy camera equipment just to take a picture through the eyepiece, and that's what that is. So that's it. What else? These are a couple of planetary ones that were also done with that first telescope. So that's a very poor Saturn. And that's and that's a Jupiter. So, but I don't do much planetary.
This one?
So
not the USB one.
We'll wait for it to sort of sound out. You're right.
Am I doing it?
Yeah, you're right. I can hear you. That sounds all right.
Oh, okay. Oh my goodness, I am so sorry. The entire time I'm like, no!
No, that's
but
all right.
I'm like, and then your picture will pop up and I'm like, wow, that's amazing. I'm so sorry. I'm so sorry.
That's all right. That's cool. I don't think anybody minds, do they?
No, but you know, I am an evil genius that is 100% tech savvy.
So I thought I'd just go for a couple more pictures and then I'll show you a bit of the kit, the
please
actual kit itself. So that's a Saturn. I don't do much planetary, but the planets are starting to come up now. So they're available. You can see them early in the morning, but I can't see them because my house is in the way where I live at the moment. But I'm moving, so hopefully I'll be getting the new house. I'll get to see them later this summer. But I don't do much planetary yet. but that was taken 3 years ago. So just before I got my first, all the blue telescope that you saw, just before I got that, this was taken with just a normal sort of click and shoot Canon. You can see a bit of the Milky Way in there. So just a normal camera again. And this starts to get into the stuff that I started to take with that setup. So that the telescope. So before we get into those, let me stop sharing my screen. And what I'll do is I'll show you that camera and
yes, please.
what I would do while we use. So here's the telescope. So we like our protected boxes. So we have the telescope itself. So
Oh, that looks heavy.
yeah, I would say probably about 4 or 5 kilos. And then we have, let's put this back down. And then we have what's called a guide scope. So that slots on there. So the photographs I take, I have to use, there are 2 different ways of taking astrophotos. One, which you use for bright objects like planets and the moon, is where you take a video. Because it's a really bright object, you can take a video of it. And then you can take that video, and there's software that will break it down into each individual frame of that video, and it will pick out all the best ones, and then they will layer them on top of each other, called stacking. So that's how you take a picture of one of the planets or the moon. You take a video and you use that method. The other method is one that I usually use, and it was where you take a really long exposure of a few minutes at a time, and then you take lots of those, and then you stack those together. So one is using lots of for bright objects on video, and the other one is long exposures. So that takes a lot longer to do, but that's what you need to do when you're just targeting faint targets like nebula and galaxies. They're very faint, so you need lots and lots of long exposures on them, and that's where the guide scope comes in. Is you not only have to take the picture with the mount, but the guide scope helps to keep everything aligned. Sort of jumped ahead a bit there, but this is that's an equatorial mount. So lots of people might have seen these on videos. This is a bit of a broken one, but it shows the principle. And this is what we use. It's a special type of mount that when you set it up correctly for your position on the globe Earth, and then the angle is set just right, basically the mount itself will follow the motion of the stars exactly using motors. So it will track the same part of the sky. So that will straight away, it gives you a certain ability to take longer exposures. But in order to get the accuracy for these, take the pictures I need an additional accuracy, which is the guide scope gives, and it feeds messages to the mount to tell it to just keep a particular part of the sky exactly where it should be, so I can get really long exposures. But it wouldn't be possible without an equatorial mount, and that's what everybody needs if they need to do long exposure astrophotography. So that's my wide field setup. That's called wide field because of the focal length. So the distance from when the light hits the lens to when it goes down the tube to where it hits the camera or where it hits the focal point is on this about 430 millimeters, which means it can look at quite a big patch of sky compared to my other imaging telescope, which
that's huge.
We'll have a bit of a better look at this one later on. But this is much longer, has a longer focal length, and basically because it's got a longer focal length, that means it'll look at a smaller patch of sky, and we'll be looking deeper into space. Hi Slim, hi Lee.
Oh yeah, we haven't said hello to the side chat.
No, we haven't had still. I actually can see the side chat now because I'm not showing parts of my screen.
I was too busy in awe and having so many technical difficulties. Sorry.
I can hear you fine.
Shall we say a quick hello to everybody in the side chat?
Yeah. Well, I've got Microraptor and Leocidary and Dora.
Mhm.
And Ox for no
so-
reason. Brainless, of course.
Yes, and the little friend that is with
And
Brainless.
oh yes, Brainless has got his young lad with him this afternoon.
So hello. And we have Neil, and we have Tina, Mr. Wonderful.
We've got a few, haven't we?
Everybody
We're
else has
well
like
into
that.
double figures.
And oh my goodness, I almost forgot for no reason. Heaven
No,
forbid we
don't forget
her.
that.
No.
Absolutely.
And there's a task who's right next to me now, staring at my mic.
True. Is it? It seems to be behaving itself a bit, but it is still quite. It has got some cracklies going on, hasn't it?
And a purple, orange, and orange. I'm still. I realized I have missed people. I think I'm caught up because we already said hello to Dora, Oxley, Slim. And a Tatty.
Tatty's lurking.
There we are. And
So I'm just thinking other things that people might, from the basic kit, that people might have seen similar before.
Sure.
Is some people might, if I was doing visual, which I don't do much of anymore. If I was out, for instance, if I was going camping with friends and stuff, I would normally go visual. So because I can, because the everybody likes to have a look at the planets and stuff. And during summer when you're camping, that's the ideal time. So I quite often I'll take the smaller setup away, maybe, or I've got another telescope in the garage as well that I haven't got out, which is a smaller version of the big one. And it's always nice to have people have a look. And you would use something more like this. You'd need a right angle, and this is an eyepiece. It's quite a big eyepiece. This is a 2-inch eyepiece, but you can
so
see
that means that there can be loads of different sizes of the eyepieces.
Well, yeah.
Let's see upside down.
This is a zoom eyepiece. So eyepieces generally go in, they get in millimeters. So this one zooms from 24 millimeters down to 8, and the lower the number goes, the more magnification you get. So this is quite nice to have because I don't have to mess about changing eyepieces all the time, having a decent zoom eyepiece. But that's what I would use if I was out sort of showing people the planets during the summer and the moon. It's really useful. And yeah, it's a nice bit of kit. But that's not what so much I do anymore. But you can also use that with it. So that bit, I think people might have seen one of these before, perhaps not quite so big, but that's let's turn it upside down. So yeah, that's the right angle. So just got a mirror at the end of it, and that helps. Because basically I need one of those because my equipment is set up for photography, so the focal point is further down the tube than it would be for a normal telescope, so I need extra bits to help bring it to focus. But yeah, so that's a refractor. At the end of it is something called a field flattener. Now telescopes bend light and they don't bend, the lenses don't bend it perfectly to make a perfect flat image at the end of the telescope. So you can use an extra lens or an extra set of lenses to make the image flat. So that helps when you're using big chipped cameras, when you've got a big field of view, because you get a slight sort of distortion around the edge of the frame if you don't use one of those. If you were using it for visual use, that wouldn't be on there. I'd have a different bit attached to it. But as I say, I don't use it for visual use very much. But what would attach to there would be one of these. And this is an astrophotography camera. So
ooh, that one matches my hat.
So this one is a color camera. So much the same as on your mobile phone or in your little pocket camera, you can see down the end there. You see that square thing?
Yeah.
that is what's called a CMOS chip. Don't ask me what CMOS stands for. I can never remember. But there's two types of imaging chip. One is the CCD chip, and I do know that's charge coupled device, but CMOS is something else. But basically, that's what receives the light. So that's exactly what's a small one of those is what's in your mobile phone camera. Little tiny one. So in fact, I've got it for the guide scope. I have a separate camera, because a separate camera takes the picture of the part of the sky I want to look at and keep, and that's so that chip in there is tiny weeny compared to the other chip. So and that's what would go into the. So if we put that into the guide scope slot, so we can basically build up a little rig as if I was going to go out to night imaging. I can't go out to night imaging because it's terrible weather, but we can pretend. So we would put that guide scope into the guide camera into the guide scope slot, and we would then, now this is M48 connection, so we need to change. We're going to put a filter holder in there. So this is all my bits and pieces. I've got all sorts in there. I've got extension pieces and extra bits and pieces. So, but this is what we're going to put on for a filter. So we use filters in astrophotography, so when we want to cut out certain wavelengths and stuff like that. So, so we unscrew our camera. Yeah, go for it.
There seems to be a lot of people that have just entered the side chat.
Ooh.
And so I just wanted to say a little hello to them, and apologies for having to turn face rig off, as I believe that's been my issue.
Oh, right, okay. Well, there you go.
So there's a
What just have to do with your dulcet tones?
I know, I'm sorry. There's a Say What? There's a Nature's Truth, and a Wonderland Walker. So hello to all those lovely people.
Good evening. How is everybody? I hope you're all well.
Yeah.
So there you go. That's basically what it would look like set up on the mount downstairs. My big mount's in the garage. I wasn't going to bring that all the way upstairs. But the mount is the most important thing, really, because as good as your telescope might be, if you haven't got a mount that is capable of holding that weight and pointing in the right direction and tracking accurately, then you're not going to get very good photos. If it moves around a lot, then you're not going to have much fun with it, and it's not going to be able to take very good pictures. So when people ask what's the best telescope to buy, it's usually what mount does it come with. You want to be asking what mount do you want to buy, because what you put the telescope on is as important as what the telescope does. So for this setup, pretty much not quite this setup, but let's see some pictures that were taken with that sort of setup.
And there's a surf as well.
Hey, surf.
Oh.
So
yeah, I'm so excited. Are you going to do the reveal, or are we waiting for a little bit longer to show that one?
What the new picture?
Yeah.
Well, what I'll do is I'll show some that was taken with that setup, and then I'll basically, yeah, I've moved into a slightly different type of taking picture. So I'll explain it in a minute. You'll just have to be patient. You'll have to be patient.
Okay, I'm sorry.
Let's go with this. So these are a few of the pictures that I've taken with that setup, I think. So this is the Horsehead Nebula and the Flame Nebula. Was it up yet? No, it's not showing. Yeah, it's not coming up. Do you need to share it at all?
Oh, sugar! I forgot. I'm in charge of this.
Yeah, this is your stream. I do. Honest.
Oh, see, I'm still getting used to this.
I can see it now.
Technology, I can do it. I can do it. Here we are.
So yeah, that's the Flame and Horsehead Nebula. So you can actually see some little dots here. and this is dust on the part of where we're probably on the front of the camera. But you can take special additional frames called calibration frames to take those artifacts out. So you'll see a lot of my pictures don't have those in, although they existed when I took the initial pictures. I've taken these calibration frames which help to make sure you don't get them.
I love that orange. I think Slim's right. He's saying beautiful, and honestly, I think it's more than that.
That's the Flame Nebula.
Word. So gorgeous, honestly.
So that's called the Bubble Nebula, and you can see why. So if you, there are probably other pictures of this one because I have done this one quite a bit. So you can zoom in and you can sort of see this. You can see it's a bit grainy, but you can see the bubble, and there's a star in the middle of that that's giving it.
So pretty.
So these are what are called emission nebula. So they're actually emitting light. Yeah, it's CGI. Absolutely right. So there's two types of nebula really. There's emission nebula where the gases emit light. They're excited, they're energized by a star or a group of stars in the gas cloud, and the gases therefore get warmed up and excited, and they emit light. That's called an emission nebula, and the other one's called a reflection nebula, where the gases are, as I say, it's reflecting the starlight. So they're not getting energized by the starlight, it's reflecting starlight. So these ones, most of the stuff I've got are what are called emission nebula. So you can see they're red in color, and that's because the gas that's giving out most of the emission is hydrogen alpha, and the wavelength of the light that gas gives out is in the red spectrum, which is why these are mostly red. If we zoom back out of that,
when you're ready, there's a question Dora's asked. Just tell me when you're ready.
Light pollution level where I am at the moment is what's called a Bortle 5. So light pollution for us is measured on a scale of 1 to 9 really, or 0 to 9, and we call it Bortle. So if you were right in the middle of the city, it would be a Bortle 9 because it's light all night. You've got street lights everywhere, shop lights. There is no it's complete light pollution, if you like. So when you start to move out to the countryside, outside sort of I'm about sort of 35 miles west of London maybe, and so there are still big towns and cities out here, so the light pollution is still bad, but it's around a 5 or 6, so there's still quite bad light pollution. But when you get out to somewhere that's got no light pollution, that's when it gets to a Bortle 0, and they don't really exist in the UK.
Oh, that's so sad.
We've got Bortle 2s and 1s, some 2s in Wales, and up in Scotland, some 2s and 1s around, but that's about it. But yeah, so these were taken in a Bortle 5, and I'm moving to a Bortle 4. So every little helps.
And you got a funny silly comment.
And does Steve photograph an only visible light as opposed to using filters? These pictures that are mostly red are using what's called a quad band filter, which is specially designed for use with a color camera. Let's have a couple of looks at them. I've got a couple of pictures which will explain
I'll pop it down
in a minute.
So you can see.
So
and then,
that's
micro.
Cool. You can see stuff even if you're in a city. Most people do is what's called narrow band imaging, which I've just started, and I'll explain a bit about that in a little while, because narrow band imaging uses special filters, not so much in UV light, but in specific bandwidths, which I've got some bits to explain how that works. In fact, so this is the Tadpole Nebula. So you can see the tadpoles in here. You can see this, and that's
I was actually going to say that's what it looked like.
So yeah, so that's quite a wide. You can see that's quite a wide field. So that was taken with microfractor. But again, this was using a quad band filter. So the filter on the front of the color camera, it allows H alpha light, O3 light, that's oxygen 3, which is another gas. So the wavelength of light that lets off, this filter lets through, and also a couple of other wavelengths as well. So the filter cuts out most of the light pollution. It really helps cut down on light pollution. It wouldn't work in a big city because it's not that strong, but when you're in somewhere like where I live, where I've got some light pollution, but it's not too bad. It really helps with that. So it's a special filter for help, but more specifically designed for color cameras. Have I been to Skye? No, I haven't. I'd love to go to Skye. I was speaking last year, going back up to Scotland, wasn't I, and getting up to Glencoe. Yeah, I'd love to get up to some dark skies. Yeah, the light pollution. Yeah, light pollution does cause a big problem for us, which is why. So yeah, so just zoomed in. Oh, a bit of aurora chucked in there. I went to Iceland 4 or 5 or 6 years ago, and there was a nice light show. We drove out of Reykjavik to go and see it. So
how was it taking all your equipment on the plane?
I didn't have any of my telescopes at this time. This was taken with a little Canon Sure Shot quick shot camera.
Wow, that's really good.
I had to get some software that unlocked the camera, because the way the camera is, it only allows you to take certain lengths of exposure and do certain things with it. But you can get this little piece of software that you put on the SD card, and when you plug it in, it opens up and unlocks all the different settings, so you can take longer exposures. So, but that's how I did these. So yeah, longer exposures. Yeah, it was quite cool.
I think I'm just going to spend most of this with my jaw on the laptop. I hope everybody likes all these pictures. I'm just in awe, honestly.
Well, this one's just coming back up at the moment, so I think this is going to be a target for me with my new camera. I'm moving to what's called monochrome imaging, narrowband imaging, but I'll explain what that is in a minute. But this is the Dumbbell Nebula, and you can sort of see the shape of the sort of cross in the middle of it. I think I've got some other pictures of this later on as well, some more sort of highly processed one. Yeah, Purple Rhyme says there's something called CHDK, Canon Hack. It's CHDK. If you look up CHDK, it's a little program. I used it on a Sure Shot SX510, I think, but there's a list of cameras it'll work with, and it'll open up all the exposure settings and stuff and allow you to completely adjust everything rather than it be all automatic. So this is an overexposed Andromeda. I need to go back to Andromeda. She started to come up again now, because obviously as the year goes on, certain things appear in the sky and certain things move. So every year Andromeda sort of comes up towards autumn time, but you can see the middle of it. You can't see much detail. It's overexposed. So this is how I learned, you need, for some targets that are so bright, you want to have shorter exposures, take more of them. And can you see just on the right hand side here, there's a star pattern. Can you see that? I don't know.
The three stars.
That's electronic interference from my camera. So that's another reason. Yeah, that's another reason we take what are called calibration shots. So this is why I've dropped the exposure down a little bit. So this is the same picture, but so now you can see the core of them. And this is Andromeda, so our nearest large galaxy. Yeah.
Oh, wow! Oh my goodness!
So this is one that most people can see. Now, you were talking about constellations earlier, and the constellation of Orion, which is now below the horizon in the evenings now, it's too low. So he'll be coming back up towards the end of the year. But you have the 3 stars that go across his belt, and hanging down from his belt are some stars that make up the sword of Orion. And they hang down the left-hand side from the 3 stars of his belt. And in fact, one of those stars is this nebula. And with some
Yeah.
from a if you come out of the city, if you go to a darker sky site with some binoculars or a small telescope, you'll be able to see the nebula itself. You won't see the color; it'll be grey. That's what a lot of people sort of don't realize. Sort of they expect to sort of, if they get a telescope and look at a nebula, to see something like this, which obviously this is made up. I think this was probably not that long, probably an hour and a half, maybe 2 hours of exposures.
Do you want to
So
know what it kind of looks like?
go on.
It kind of looks like, you know, when you have like black ink and then you put
Yeah,
like a blob of like white with like a reddy color.
yeah,
It
I
looks
know.
like
It's
you
sort of in water.
yeah.
Yeah, well, the dark bits are actually dust clouds. They're not gaps in the nebula.
Oh.
They're actually dust clouds that mean you can't see past them. So those dark bits are actually dust clouds blocking the light. And you can see that's actually been overexposed in the middle of the nebula there. If we zoom in, we'll see later on there's a better one. So you can see that middle part is all bright white. That's not the ideal. There are some better pictures I've got of it which show the middle.
There's better than that. That's
That was the first one I took of that one. So this is the Whirlpool Galaxy. This is I've got a better picture of this later as well for you, M51.
Oh.
But this was one of my first ever targets. So I was really chuffed with getting. I think this was 3 years ago. I took this picture, and that was with just a DSLR. So yeah, so. An old Canon DSLR with a special fitting that allowed me to clip it onto the front of my telescope and take that. Let's just see. So yeah, well, I'm just thinking you probably don't want to be looking at pictures all the time. So
I think a lot of us will be fine with that.
Okay. Well, let's just do a couple more then.
Yes, please.
Okay. So
I love
M51.
them so much.
So that's a bit of a close-up of M51. So you can see it's a spiral galaxy, and one of the ones I've got later on is a better picture of this, and I've got to get even better pictures. But it's actually two galaxies interacting with each other. So the blob on the right is a much smaller galaxy that's being pulled apart by the big galaxy.
Oh.
This is called the Monkey Head Nebula. I wonder if you could tell why.
I see it.
Yeah, absolutely. Yeah.
That's so cool.
So yeah, this was another one with these are all with my refractor, I think. So I've only had the big telescope since the end of last year. But this is again using that filter. So because it cuts out most of the light pollution, it lets through a lot of HA, and the HA gas, it comes out in red on a color camera. I'll show you why that is in a bit.
You okay?
Yeah, just a bit of a cough. And that's a green version because I misprocessed it and I thought it looked quite cool. So yeah, just you can process them in different ways to make different colors. Now this is quite a dull one, but I've got more. This is my favorite nebula complex, the Veil Nebula. You can see at the top the Witch's Broom Nebula, because it looks like the Witch's Broom with the bright star riding atop the middle of it.
That's cool.
And then on the bottom right-hand side, you've got what's called Pickering's Triangle. There's a triangle of interlaced.
I'll pop Dora away for a second.
So there's a triangle of interlaced nebulosity there. Ooh, that's a big word. This is my favourite part of the sky, and you'll see I've probably got loads of these next, so we'll go through them quite quickly. So that's a brighter version. That looks a bit better. That's just slightly more tweaked, but you can see in here the color coming through. So it's not just red from the hydrogen alpha, but there's also a lot of what's called O3, oxygen 3, which comes through a sort of turquoisey blue. So in some of the later pictures, see, I've tried to push it a bit far there. There's a bit of light pollution in there. That's not so great.
Still amazing, isn't it?
So the other side of that nebula, so this is one, if you imagine, if we come back to here, imagine that Witch's Broom is the top of a circle, a big broad circle that encapsulates the triangle and goes around the other side. And at the bottom of the circle is this one here. So this is NGC 6992. And this is at the bottom of the circle. So that there's a massive, great big circle of nebulosity that comes out all beautifully blue and red.
It kind of looks like the dog from Nightmare Before Christmas. Zero, I think his name was. It's really cool.
It's called, the bottom end of it's called the Bat Nebula. So down the bottom
Ooh,
right, the bat.
so
Yeah,
let's stay spooky.
that's the Wizard Nebula. Now it's supposed to be his hat. The red bit's supposed to be his hat, and he's supposed to be firing fireballs out of his fingers. But I don't know. But yeah, that's one of my first pictures with my first ever setup. Actually, I need to go back to that target. I did do a Messier marathon hunt, not massively so. Through March, I was going to go after them all on one night, but it's not a great year for it this year. But I did take a particular picture throughout March and I will show you that later on. Of something called Macarian's chain, and so yeah, there's a particular has got 2 or 3 Messier objects in the picture. I'll show you that in a bit. That's the Pac-Man Nebula. I think that's.
I wonder why.
Yeah, I think if you go like that, maybe that might look a little bit better.
Oh no, it's really cool.
So that's in Cassiopeia. So that's quite cool.
Everyone's saying it kind of looks like a Fraggle.
A Fraggle. I suppose so. I don't know. Some sort of monster for sure.
It's pretty cool.
That was off target, so that's not particularly brilliant, but that is part of the Crescent Nebula. There is a better picture coming up. See, that's the full frame. You see, this is what happens when you're not sort of paying attention. It's a great picture if it was actually on target. So the bottom there, you can see what the target was. I think I've got a better one somewhere. So this is a different. That's a slightly different processing of the
my goodness!
So.
Sorry, just got overwhelmed with excitement there.
Oh, the wizard looks like a Fraggle, not a Pac-Man. Sorry.
Oh, right. Sorry.
So this one's quite dull, but it should be brighter red than this. But I pulled back on the color because you get the detail in it a bit better, and that's the Rosette Nebula. So that's quite a big. So if you imagine each of these, the full moon would sit comfortably in the middle of frame. You can fit probably 5 by 4 full moons into that picture. So that's how big a part of the sky you're looking at.
Wow.
So if you look at the sky, this particular object covers, a good 8-9 moons in size. It's a big old thing. And that's just to the west of Orion. So that's just going at the moment as well. So it's not available for pictures.
It looks like it looked like a cute baby alien looking up to the sky. That's his eye.
With his big mouth. Yeah, I can see what you mean. Yeah, there's a star cluster in the middle there as well, which is what's energizing all the gas around it. That's one of the crescent that I was looking earlier, but it's not a very good one. The colours are like the stars. I have got pictures of the Jellyfish Nebula. So
oh my goodness.
So that's the moon. It's not a very good one.
Yeah, you see the rabbit in it.
About that,
Can you see the rabbit?
The rabbit. The Japanese call it the rabbit, don't they?
Yeah. And
it's not very well processed because when you zoom in, you can see.
Oh wow!
You can see it's all pixelated, so it's a bit overshadowed.
Still amazing.
I need to get better at my lunar stuff. I need to get better at my lunar stuff. I think. Okay, this is the Christmas tree nebula with the cone nebula at the top of it. So you can see it's in the shape of a Christmas tree, the whole thing. And right at the top, if you zoom in, there's what's called the cone nebula. So if you go to the top, you can see that cone shape feature.
Tati says he's spotted the goat.
There is no wizard sleeves nebula, no. There are some funny named nebulas though, for sure.
That one's pretty awesome.
I think that's just the case. So those are all ones I've taken with that setup. That setup I've shown you. And I've got some bits here. Let's where are we? So I don't know whether it's going to be of interest at all, but just to explain a little bit of back to school.
Oh yay!
So just to explain, I've got a couple of, actually, no, not that one. Let's do that one.
Okay. Well, I'm in charge. I'll have to show you.
I'll just share screen. Which one I'm going to share window? And let's go for that one. There.
Then I'll have to
Right.
click the button that makes it happen.
Yep. Hopefully that'll work. Yep.
There we are.
So, just to explain, on a color camera, this is what happens with a color camera. So these are all the, you know, when you hear people talk about a 1.2 megapixel camera or a 10 megapixel camera, well, this is what it means. These are called pixels, and what they are is they're little electronic devices that receive light. So they can recognize when a photon, a light particle, hits the lens, and it can register that and turn it into an electron, which means how we can take a picture. Now, to take a color picture, like if you ever looked up close to a television, sometimes you can see blue, green, and red. It used to be on the CRTs you could see blue, green, and red, but all the color pictures on a TV are made up of these three colors: blue, green, and red. So you don't actually have it's always a mix of these three colors. So to make a color picture from a megapixel camera, CMOS camera, they cover each of one of these pixels with a different color filter. So each pixel takes a different color picture, and then they combine them using the special software to make the color picture. So that's how a color camera works. So that purple one that I just showed you, so this one here, so that is a color camera, and that has a color chip in it that has that layering over the top of the pixels. So each pixel has a filter covering it up already in either green, blue, or red, so that when the picture comes out the other end, it can be turned into a color picture without any problems. So what I've started doing though is I've started working with a different type of camera, and this was got this week, and I sort of said we might unbox this, didn't I? It's not quite an unboxing, because the picture that at the end, well, towards the end, that we'll look at was taken with this camera. So this is, it looks very similar to the purple one, but it's red. That's just a different manufacturer, but this one has the same sort of chip or similar chip. You can see if you look down there, you can see it's got a CMOS chip in the end of it, but this one doesn't have that color matrix over the front of it, so it can't take color pictures. This is called a mono camera. So the pictures it takes are black and white, but because exactly, nerdy unboxing stream, because it doesn't have those pixels over the front, it means it's 4 times more sensitive. Because obviously, to get a color picture, you've got a load of pixels with red, a load of pixels with green, a load of pixels with blue. So you're immediately having to take sort of 4 different pictures with the same number of pixels. So for the same number of pixels with this is 4 times more sensitive. But I can't take color pictures with just that. So what I need is this. So this is what's called a filter wheel. So in here, oops, just dropping the caps off, don't worry. That's all right. So what in here, if I can take it apart, are a set of filters. Now, the colors that were on that matrix, what's called the Bayer matrix, were red, green, and blue. Yeah, so each of the little pixels had either a red, green, or blue filter across the front of it. So now we don't have that on my new camera, the mono camera. So in order to make a normal color picture, I have to have red, green, and blue filters. So that's what I've got here. Once I've unscrewed everything, in here, LUTs.
What is an LUT?
What's an LUT? Oh God, I daren't ask that question now. It's going to be something that's tatty, isn't it? It could be anything. So here we go.
No.
So in here, this is a filter wheel, and if we look at my numbers, so basically my first filter is clear for focusing. You can still see me. Now my next filter is red, and then it's green, and then it's blue. But what I've also got in here, because I'm using a sensitive mono camera, I've now got what's called, now you see, it can't even see through that, can you?
Hi.
So
I see your camera.
Yeah, so that one. Now that is what these are, what's called S, H, and O. So the filters are for S2, so sulfur. So basically the wavelength of light that sulfur gives out when it's excited. And H is for HA. So we've talked about HA gas earlier on. So there's a filter in there that will only let through the wavelength for HA gas. And the last one is O3. And so basically now my mono camera, when I use it with those filters, will only pick up those particular wavelengths of light. And those 3 wavelengths of light are what most nebula give off. So when you image in those particular wavelengths of light, you can do something what's called the Hubble palette. So if you've ever seen a Hubble space picture, they're all blues and yellows and really lovely colors, and that's what they're doing. They're assigning those 3 wavelengths of light to red, green, and blue. So instead of it actually being a red, green, and blue image, the red is sulfur, the H is green, the hydrogen alpha is green, and the blue is O3. So they map those particular wavelengths of light to that color spectrum. So it makes us for us to look at it, it looks very different. So I don't know whether that makes sense.
It does.
Sort of.
Yeah. I think it's just a little difficult for me to grasp.
Well, let's see. Let's see if this helps. Yeah, let's run that. I'll pull this up. Right, let's just share that and see whether this helps.
Oh, Tatty wasn't being a wind up.
What's LUTs?
Look up table.
Oh, right, okay. I know what you mean. Well, I don't really need to worry too much about that because it's. I'll show you in a minute. Before we do that, can you see? Can you share that one?
Yeah.
Yeah.
I was just waiting for when you were ready again to go back to it.
I'll just explain here. So that's the visible light spectrum. So you can see the rainbow there. So it goes from red, orange, yellow, green, blue, indigo, violet. So that's the light we can see. So you can see the wavelength here is in nanometers. So basically, HA looks red to us. So all those red nebula pictures we were looking at earlier on, I was saying were HA emission. So that's the wavelength for HA is up here, which is why it looks red. So that when that gas gets excited, it gives off a light in this wavelength. So the filter that I've got, the HA filter, will only let through light in that wavelength. It's especially chemically engineered to block off light from all this way down the other end of the spectrum. So it'll only let through white light, and the same is true for the other gases. So one of them's in the green spectrum, one of them's up here. So that's what the wavelength and filters do. They help to block out all the rest of the light, so you're only letting in the very little bit that you want to image with. And that's what the mono camera is letting me do now. So yes, that's going to be going forward the way I want to, what I want to do. As none of this kit is cheap, as you can probably imagine. But yeah, my birthday was recently, so I treated myself to that new camera, and that's what goes on to this beast here. So let's have a quick look at Colonel Ken. He's named after my granddad.
Oh,
because some inheritance helped to buy him. So yeah, this is a big old Newtonian telescope. So the other one we were looking at has lenses in it. So it's got glass at the front, like a traditional telescope. Well, this one, and same as this up here actually. So this is another type of guide scope. So, but this one here, if we can actually look down it, so be careful.
Oh,
so
don't
look down.
Oh,
you should see down there. Down there, you got a mirror. You got a mirror. and the bit that's blocking that you can't see is the secondary mirror. So the light goes all the way down to the end of the big mirror at the bottom, bounces off that big mirror onto the little mirror that's at the top on those crossbars there, and then it goes down to the eyepiece hole, which is on the top there, that's got the little red box attached to it, and that's my focuser, and it's got an electronic focuser attached to there. So this is my complete automatic setup. So I can plug everything into this blue box that was on the side there, which is a special power box, and then I use this here, which is a Raspberry Pi. So
what I thought was actually a Raspberry Pi. Remember?
No, this isn't one of those Raspberry Pis. So this is just a little tiny computer, and on there is all the software I need to control the mount, which is the main bit, and also all the cameras. So this all plugs into there, and I connect to it via Wi-Fi, and I sit in my office up here and control it all from up in my office.
That's
so yeah,
good.
so so you can do different types of picture with that setup. So what else? Let's show a couple of other pictures then, because people like pictures, don't they? So what we'll do is we'll go we'll go to this lot here. So there are some goodies and baddies in here.
There's been a couple of questions.
Yeah, okay, what do we got?
If you don't want to answer Tusk's one, just say next.
Very polarizing. Very good, Tatty.
If you don't want to answer, say next. If you
right, okay,
that's okay.
I will admit that it's I don't think it's far off 5 figures so far. I've been doing it 10 years though, so my initial setup, which was a good telescope on an equatorial mount but for visual use, was probably about, I think they're around £400 now. So as far as in another life, I am a mod on an astronomical Discord channel. There's a YouTuber called Astrobiscuit who does he does astrophotography on a budget, so he buys second-hand gear and that sort of things, and I'm a mod on his Discord channel, which, and one of the questions we always get asked is what's the best telescope to buy, and it all depends on budget. And yeah, if you're going to a toy store to buy a telescope, you're not going to get something very good. So you can expect to spend sort of minimum of £100 for something that's okay. But it's one of those things that if you enjoy it, you'll invest in it. And yeah, to sort of take good photographs and stuff, you do have to put a bit of money in any unfortunately. Cameras do get very expensive very quickly. That's my latest one. That was my in-laws were very kind and gave me a very generous check for my 50th birthday, and I bought that with it, and that was £1,400.
Wow.
So yeah, to do some of this stuff, it can be very expensive. But at the same time, as I said earlier, there are people that do this with a mobile phone attached to a telescope, and so it can be got into, and you can start it really, really cheaply. There's no reason why you couldn't buy a sort of what's called a Dobsonian telescope. So it's very similar to the big Newtonian. But instead of being mounted on an expensive equatorial mount that's used for astrophotography, it's mounted on a very simple wooden rotating moving mount. And you can get great images through it because they've got a big mirror like this has, but they haven't got any expensive motors or anything like that on a mount, so they're easy. They're cheap to manufacture and cheap to buy, but you can get great pictures of the moon and the planets with those. And that's using a mobile phone with a clip on it, and you could progress to that, maybe putting a little camera onto it, something like where are we? Where does that go? Oh, there you go, something like this one on the end here. So this is a little camera I use for guiding, but is also very good as a camera for planetary and lunar photography. So that's just over £100. So again, it's not a cheap bit of kit, but if you start to get into wanting to take good photographs and wanting to do it's that's almost like a gateway drug, shall we say? Because it is very much a case of once you start, it's very difficult to stop. It's a big rabbit hole, and yeah, I've spent a lot of money, but I know people who have spent 10 times what I've spent. There's a couple of guys on the server who there's one guy who has he's in the States, and he has a remote observatory that's 300 miles from where he lives in the mountains, and he's got 2 telescopes in there, and one of his telescopes on its own is £8,000. So you can spend an awful lot of money, but you can get into it quite cheaply as well, as long as you're sort of aware that you're not going to get pictures, say like mine, with a mobile phone. So let's just share a couple of
so there's a lot. But Mike was asking if you've ever seen a blue police box flying around.
No, but I have seen the ISS, and it is an ambition of mine to photograph it. It is possible, very possible with all my kits. Should be quite relatively easy to do. It's just I'm normally set up for deep sky photography, so if there's a clear night, I'm quite often. But in summer, that might be different. So yeah, I may well end up sort of doing a bit of sort of trying to get planetary, which is a much different discipline to long exposure deep space photography, and it's much more suited to ISS as well. So maybe I'll get ISS this summer.
I'll keep my fingers crossed that you'll get to take that picture as soon as possible. For No Reason made a good point, saying asking what telescope/camera to buy is like asking what's the best dinner to buy. It's all dependent on the person and what they're trying to
Exactly true. Exactly. That's the first question that's usually asked, is what do you want to do? Is it for visual or is it astrophotography? Because people's expectations are that you can buy a £100 telescope and do something like this, which is just not possible. See, Tusk, have I discovered any astral bodies? Only my wife's.
No, I'll send this to her. Timestamp. No, I'm kidding.
No, I haven't. I mean, the people that sort of do that are usually sort of have much bigger scopes than I have. There are people that do sort of amateurs who do research of that sort of type. So they for comets and stuff like that. So amateurs do discover stuff. If you want to share my screen again.
I just noticed it. I was too busy watching you.
So yeah, this is one you'll recognize, but this is a bit, you can actually see this is a picture with, you can see it's taken with my Newtonian because it's a much closer in view, but you can see where it's actually 2 pictures spliced together. I don't know, can you see mine? You can't see my mouse, can you? I don't know.
Yeah, I can see your mouse.
Yeah, so it's just down that line there, you can see there's a little bit of a line. So that's where, so there was another one here as well. So that's 2 pictures spliced together to make, because my field of view is smaller on but you can get much more detail with the Newtonian because it's got a much bigger mirror. So and you can tell it's within my Newtonian because the star, that star pattern only happens with Newtonian telescopes because of the cross members that hold the secondary mirror in place. They make that diffraction pattern. So that's why you get the cross in it.
So like if somebody else took a picture with the Newtonian camera, you could tell because of that?
If you see a star like that in pictures, it means that the telescope that was used had a mirror in its image stream with a secondary.
It does get a lovely, like, is it that shows the halo effect, or?
No, the halo is basically down to poor processing and the fact that I was using a filter, so that shouldn't really be there.
Oh, sorry.
No, that's all right.
I thought it was really pretty. I like
it. It is pretty.
There.
And well, when we look at the pictures later, the last pictures, the new ones, The one that I showed you, which is
Oh.
is really pretty, but it's a terrible processing of a picture because the colours
It
are all.
is?
But
I
exactly,
thought it
yeah.
was
But
amazing.
I'll show you a couple of the others. Yeah, and NASA actually sends me these pictures. I actually haven't spent thousands on kit and
No.
years
Oh,
learning
no.
how to do it all. NASA just sends these to me. Yeah. So this is the Bubble
Okay.
Nebula again, but processed in green. You can see, see that
Oh,
halo around
wow.
that star. That's because of the filter I was using. So this is exactly the same. All I've done is instead of processing the H alpha as red, I've processed the H alpha as green.
I really like that. I think this one, other than the secret one that will be shown later, I think this one might be my favorite, and the witch's broom that you
Yeah,
just showed as well.
yeah. So this is my big mount out in the garden. So you can see it's slightly bigger than the one I showed you earlier.
How tall is it?
That comes up to just past my waist, so I would say that's about sort of 3.5, 4 foot tall on those legs. So it's not massive, but it's tall enough. And you can see all the wires there now. Obviously, it needs all sort of be cabled in and attached to various bits and pieces. So just some pictures of that. I think this is the Flaming Star Nebula. Sorry, it does say up on the picture up there. So again, just an HA, but that's quite a big area. HA emission in it. Yeah, quite nice. And again, that's the whole thing. So whereas this bit, if you look here, that's just one part of it. That's the top part. This bit is actually the wider field taken with my other telescope, my little telescope, which gives a wider field of view. And that's the whole Flaming Star Nebula, almost in like a comma or a speech mark shape. But again, light pollution down the bottom. You can see what's called a gradient. So down the bottom, it looks much more sort of grey and white than it does at the top. And that's something I didn't process out. So again,
really cool,
my processing poo, but so that's another one. So that's the tadpole again. We've seen the tadpole before. That's the Sadr region in Cygnus. So coming up in the west at the moment, sorry, in the east, everything rises in the east. If you look at about sort of 11 o'clock at night, you'll see a cross low in the eastern sky, and that's Cygnus. And Cygnus has the largest region of nebulosity. It's where most of these pictures I've been showing you, all these nebula are in Cygnus, most of them. It's a massive. That's bad processing. That's bad darks. So you can see things can go wrong. You can spend
cool.
You can spend hours and hours and hours taking pictures, and it can go quite drastically wrong. So now we're into.
Oh my goodness!
Yeah, this is where I've some of my favourite stuff. These are some of the things I'm most proud of. So this is the Elephant Trunk Nebula, and it's not the whole region. It's actually bigger than this, but this is stitched together from 4 different nights. So this is probably about, I would probably say about 14 hours of exposures in total, and four or five panels have been sort of all stitched together to make, and you can't really see the joins. It's done quite a good job of it, but that's what.
That bit is so cool, where you just circled with your mouse.
That is the elephant's trunk. So in fact, if we have a look, I've got, there we go. So that's it taken with my. Now you can see the difference. Now if you look here, if you zoom in, you can't. Oh no, if we zoom into here and you look at a star, the stars are all points of light. Yeah, all points. So if we come out of that and we go to this one, you can see the stars are now not points of light. They've got those crosses on. Oops. Oh, why is that? There we go. So they've got the crosses on. Yeah, they're quite pretty. So that means this was taken with my Newtonian. So although they're the same subject, they're different pictures. So you can see with this. I only get in trouble when I do my exposures in public, Dora. Don't worry. I try to be careful. This is the Heart Nebula, for obvious reasons. And you can see this is made up of 3 pictures. So you can see the steps where the 3 pictures are sort of joined in. And at the bottom there, I've cut it off, but it's the Fish Head Nebula.
Oh, I do sort of see where the the fishes there, and
Yeah,
it's
it's
undeniable that you can
sometimes
see
called
the
something
heart.
else, but we won't go into that.
Uh-oh. It's a fish.
It's a fish. It's a fish. So there you go. So that's a sort of bigger, wider area, a better picture of the whole thing, but in green this time. But yeah, not very well processed again, but you can see the fish head nebula a bit better there.
Oh, it does look like a puffer fish.
And this is the Soul Nebula. So right next door to the Heart Nebula, over to the left somewhere, is this one. This is the Soul Nebula. So the Heart and Soul sit close to each other in the sky.
Oh, that's really lovely. Don't you think?
If you've got a short enough focal length, so so my big one is 1,000 mil focal length, and that's quite narrow. You could look at a small bit of sky, and then the other telescope has a 430, so that's a shorter focal length, looks at a bigger bit of sky. So what I need is one that's got an even shorter focal length that will leave it, even a bigger bit of sky, and you can get both of them together.
Wow, that's quite.
See, there's always stuff on my shopping list. There's always different telescopes and things to get. I'm not allowed to spend for a while though. I've got to get used to all the kit that I'm using. So this is the Pelican. So this will be one that we is the picture we're going to show later on, but a different version of this. So So this is actually, if we do, can we flip it? No, can't flip it, can I?
You can turn it with the other one.
Will it allow me to?
Not that one.
Yeah, I can rotate it. I want to mirror flip it. That's all. Just so
so if we no idea.
If we go rotate, flip, there you go. So now that looks more like so if we open that, oops. So yeah. So that is the Pelican Nebula. So you can see if we look at, I need to go and find that now, don't I? There we go. There we go. So here, so this is the Pelican's back and neck up to his head, and that's his eye in the middle.
Yeah, I see
you've got his beak there and his beak there. So it's a big, long beak, pelican beak, and there's his back and his tail. So that's the Pelican Nebula, and that's the picture we're going to look at later, but a different version. So that's with my old camera. So that's with the refractor. That's quite wide field. So let's cancel that. We don't need to look at that. Cancel. Okay. Oops. I stopped sharing. I think that's probably.
If you need that.
I'm just thinking what else we could look at. There are a few more in there. Let's keep looking at pictures because there's some nice ones there. Let's start with that. So there we go. I'll open it up again. So yeah, all of these were taken in the last 3 years. I did do some astrophotography planetary before. Oops. Don't want that. Oops, there we go. So share screen. Yes, I know. That one, photos. There we go. So this is Jupiter. This was taken with a friend's telescope, which has a much longer focal length, which means you can get really close to planetary targets. It's only a small telescope, but it does a really good job on planets. And you can see Jupiter's red spot there. That's my first picture of Jupiter's red spot, so I was quite pleased with that one. So planets are quite fun, but mostly during the summer. Have I ever gone abroad? I've not gone south of the equator. I went to Singapore to see the eclipse a couple of years ago, but no, I didn't get south of the equator. This you can see all the dust spots on, which I'm really annoyed with. But this is the Leo triplet. So these are 3 galaxies that are quite close together to each other. On the left is the Hamburger galaxy, and I think it's M65 and M66 are the two on the right. They're what's called Messier objects. So they're part of what's called the Messier calendar. 110 objects, 112, and they're basically a catalogue of nebula and galaxies that were seen many years ago by Charles Messier. But yeah, these 3 sit all close together, so they make a really good photograph.
Yeah, It's really cool. I
You can
do like the. Oh, now I've forgotten the name of it. The one that's tilted like to its side, and you can almost see the middle.
that one or that one?
Yeah, that one. That one.
That one. Yeah, that's
Yeah,
M66, I
I
think.
do like that one.
You can see all the clouds in it. I mean, it's quite cool. I mean, consider it does make me. That's one thing I do. That's the one thing that. Well, the main reason I do it really is the fact that I can take these pictures from my back garden. What's my favourite song that involves the universe?
Oh, what a good question.
Princes of the Universe. Oh no, I don't know really. I'll have to have a think on that. Maybe we'll come back to it. I like Queen, so that's Trio Triple again, but not quite such a good picture. There's the dumbbell again, so I think we've seen that picture before though. There's the close-up version of the dumbbell. That was taken with my newer telescope end of last year, so you can see much more detail. I can get in much closer with the bigger telescope, and hopefully I can do an even better job with Masters of the Universe. So maybe that's what I was thinking of. So that's the wide field shot with it. So that's I need to get the Newt running properly. So again, that's Andromeda. That's a bit of a better picture of Andromeda this time. You can see I haven't over processed the middle of it. You can see the core quite. And there's a better picture of Orion. We were looking at a picture of Orion earlier.
Yeah.
So this is one I did earlier this year. If we rotate it so it's the right way around. So yeah, you can see if we zoom into the middle now, where it was all white before, you can now see a little trio of stars in the middle there. And yeah, so you can, but yes, so yeah, that's a lovely target. It's very bright as a nebula. It's very rewarding. You get a lot of detail in the nebula itself. So that's M42, the Orion Nebula. So that's the one that's the sword of Orion's belt, and just above it is Demaran's Nebula. So yeah, very rewarding target, and one that a lot of people do for their first astrophotography target, because it's nice and easy to find, and it's nice and easy to get a decent picture of it. You can do that with the moon as well. So this is Pleiades, 7 sisters. So there are, I think it's 1, 2, 3, 4, 5. I can't remember which the 7 are. It's probably 1, 2. But you can see here now. This is what I was talking earlier. This is the reflection nebula. Instead of the gas getting excited and emitting light, this is where the gas is being lit up by the stars. So you can see the wispiness there. So you can see the wisp cloud. So that is the nebulosity, but it's the stars reflecting in the nebula. It's not actually giving off light. So you need a different type of filter to take these pictures. You can't use what we call a narrowband filter, like I do on the mono camera, because these don't emit any light. They're reflecting lost starlight, so it wouldn't work. And that's a bad picture of Pleiades. Look at all those dust spots. So this is what happens if you don't take what's called calibration frames, flats and darks. Pillars of Creation. I wish I could get a picture of the Pillars of Creation for no reason. I am moving. Hopefully by the end of next month, and I will then have a better southern view. At the moment, I've got no view to the south, and that's where the Pillars of Creation are. They're in the Eagle Nebula, which is very low on the south, and I just can't see it at the moment, which is why I haven't got a picture of it. So, yeah, Pillars of Creation are very much on my list, much the same as the ISS is. So, yeah, one day. So come back to me on that one. So this is M51 again. So this is I think this is probably a recent one actually. I think this is my first attempt at monochrome imaging with my one of my little guide cameras. So that's the same galaxy we were looking at earlier, but just in much more detail. And you can see the dust lanes going through the spiral. Sorry, go on now.
You know, if you could get that in like a little orbed necklace,
Oh,
how
you
cool would that be?
probably do that, yeah, and get a decent picture of it to put in it. I'll see if I can get you one. See, that's a bit better processing now. You
Oh,
can
it's
start to
so
see,
cool.
and you can see all those sparks, see all the little specks in there. They're
Mm-hmm.
actually nebula. So when you
Oh,
use an HA filter, you can actually pick out, and each of these nebula have got designations because they're so bright within M51. But you can see this other galaxy being pulled apart by
oh.
M51. So yes, nature at work. This is my first and only picture of a supernova. So this galaxy
Oh,
here, M61, last year in May, had a supernova go off. I'm just reading questions here.
yeah.
I'm quite happy to provide people pictures if they want. Yeah, so
Oh, sorry.
every now, basically, they reckon once every 100 years or so, a supernova goes off in any given galaxy, as a rough estimate. And we're overdue one in the Milky Way from quite some time. But when a supernova goes off, the sun explodes with just so much power that if it was in the Milky Way, the last time we had one in the Milky Way on Earth, we could see it as a star shining in during the day. That's how bright it was. So if you look at this galaxy, this little dot here is AT 2020 JFO, and that is a star exploding in that galaxy. The stars you can see either side of it, the dots you can see either side of it, are actually stars in our own galaxy. And I think the difference is, I think the stars in our galaxy are something like sort of, I think 10 to 12 million light years, is it 10 to 12,000 light years away? But that star there is about 50 million light years away, but it's shining with the same intensity of a star in our own galaxy.
Oh, I'm just saying, looking at the window, like, wow. Imagining how far away
It's
that
all
is.
up there. That's the thing. It's all up there. Once you sort of, I'm very lucky that my kit I've built up over the years is automated, so I can just when my Wi-Fi is working okay, I can have it all running and working really quickly. And I don't need to sort of be outside to look through finder scopes and align stuff. I still need to do some aligning. This is one of my favorite pictures.
Ooh.
This is Bode's galaxy and the Cigar galaxy. So Bode's, or used to be called Bode's Nebula, because when it was first found, people thought it was a nebula. We didn't know about other galaxies at the time. But yeah, these two are very close to each other again. I think about 30 million light years away. But if you zoom in on the Cigar galaxy, you can start to see some details. You can see cloud structure.
Like the dark sort of.
Yeah.
What would that be called?
That's again, it's gaseous. It's clouds of gas blocking the light, so it's not gaps there. It's just you can't see. And then Bode's galaxy, you can see I've overprocessed a bit because they're square pixels, but yeah, you can see the swirls of the spiral arms.
It's really
it's a very pretty galaxy.
Honestly, a lot of this stream, I don't think I can say much other than wow.
What's next?
It's so amazing.
This is M101. This is called the Pinwheel Galaxy because it looks like a pinwheel firework. Now this one is, you can actually see, again, you can see lots of little dots in it. This has lots of nebula patches. So when you take this with an HA filter, you can see lots of HA nebula blobs in the middle of this spiral, and it's just spiraling out. And in fact, you can just start to see out here the spiral arms go all the way out. So if I was to spend some more time on these, which I will do as time goes on, they're very comparable sizes for the most part. I think Bode's galaxy, the last one we were looking at, Tusk, is bigger. Andromeda's slightly bigger than our galaxy. but yeah, we're all, the spirals are all quite similar sizes, I think. Some are bigger than others, but yeah, I think the ones I've shown so far are all fairly similar. Right, this is
Is that
now, is it my favourite one? I think so. So this was done. We were talking earlier about a Messier marathon in March. Instead of doing a Messier marathon, I throughout the whole of March, whenever I could make pictures, I took pictures of this part of the sky, and this is this is in just outside the Leo constellation. And this is Macarian's chain. So there's a line of galaxies go up through the middle there. So there's 1, 2 at the bottom, and then there's 2 paired there, and then 2 paired there, and then final 2 at the top. So there's 8 galaxies in the chain, but you can actually count more than 30 galaxies in this image. So when I posted this for the first time, I sort of said, there's got to be some life in there somewhere, hasn't there?
I hope so.
But you can zoom in out and see all these other little galaxies. So if we zoom in, so there we go. There's a little one there, and there's a little one there, and there's a little one there, and there's one there, and one there. Little spiral one there.
Ooh, I know it's not tiny, but it looks tiny.
Yeah, that's one up there as well. That's a galaxy. There's 3 Messier objects in this picture. There's another one there, another one there, another one there. So loads of galaxies just everywhere. It's see the little tiny fuzzies we call them, because they're tiny little fuzzies in nice pictures. So cool. So yeah, so that's one of my favorite ones from recent times. And that's Mars.
Ooh.
So that was taken towards the end of last year. Yeah, you can see that little white dot on its top is actually, that's the South Pole. It's actually upside down for visual use, but that's the South Pole with the polar cap. So that's a polarized cap reflecting the light. And this was taken slightly later in the year, and you can see the bands and actually see details of Mars on there. So very pleased to get that as well. These were my first pictures of Mars. So and so a bit more zoomed in there. So you can see actually on the right hand side is the polarized cap. Now that little tiny white dot's got a lot smaller because it was several months later and it's just melted away. So it's coming back towards us now. So yeah.
Right.
So should we start to see her in November time? We'll be able to photograph her again. A bit dimmer. And this was Comet Neowise last year. So again, this was it was my first attempt at a comet. So you can see the 2 twin tails. You can just about see the twin tails of the comet there, which is quite cool. And back to the wizard. That's California Nebula. Everybody reckons one of the most boring nebula in the sky, but that's actually 3 panels. It's such a big nebula. You can see the lines of the panels there.
How is it boring? It's beautiful.
Yeah. It's
Why
a big
do
old thing.
Boring?
Just because there's not many features in it when you look at some of the other nebula we've got.
I think it's pretty cool.
So now we're getting closer towards the last few months now. Cocoon Nebula. Yeah, nice purpley pink colour. It's very pretty. And that's the Crescent Nebula, but in green. So you can see that's what the Crescent Nebula looks like. In fact, have I got a normal? Oh, that's terrible. Yeah, that's a bit better. So, so yeah, that's why she's called the Crescent Nebula. I need to get some proper time on it. Thing is, now I've got pictures of most of the common nebula now, but the way to go is to take more time on each one. So from here on in, I'll probably be spending sort of many days taking pictures of the same subject to get a lot more detail. And that's the full picture of the crescent, so that's quite nice. You can see all the nebulosity around it as well. So it's not just that bit in the middle. It's you can see all the red gas around it as well. And a backwards picture.
I like that one.
Right, here we go. Back onto the witch's broom. So this was just after I got my newt, the collimation spot on. But yes, you can see much more detail in it now.
And you used the mirror one.
Yeah. So in fact, let's yeah.
See, I'm remembering. I'm retaining some information.
Yeah, and you can tell because it's got the cross on it. The stars have got the cross, so you can tell that's
I do really love this one.
yeah, it's a pretty nebula. So that's not such
Oh
great
my
processing of it.
goodness! But the colors, though.
Yeah, you can sort of change the colors. You can push them in different directions. So when you're playing with processing, again, another one of the same subject, and a bit brighter this time. You see, pushed up the exposure a little bit, and yeah, it's just lots of different things. So yeah, so that's it in a wider field using my other telescope, and you can see the Pickering's triangle down below it. Yeah, so and that's the opposite on the big circle.
Is that the bat bit?
Yeah, the bat bit's down at the bottom there, the bottom right. That sort of the bottom chunk of it is called the Bat Nebula. Hey, Global Mum.
Hi.
And that's a purple version. Yeah. That's
my goodness.
So it's just changing colours when I do those. So you just change.
Do you have like a
processing.
favorite colors you like to put them in, or does it
well,
depend?
these are the natural colours. So these are what they should look like. So that's a lovely big wide field view of the Eastern Veil in its natural colours. And I think I prefer those, but because you can start to see the orange, the bluey bits coming out at the bottom. So if you get enough time on it, they look amazing. And that's the purpley version. I think you prefer that one. Probably.
I do. I like cool colors.
And that's the
bat.
I
also think these are amazing.
Yeah, so that's the bat just at the end of. So if we go back and look at that one, you'll see the left hand bit. Is the
try and find the bat.
Yeah, so I don't know. I don't know which white. Yeah, but it's called the bat. Yeah, I don't know. Some of these don't really look much like it to me. That's not a very good picture either. But
no, it's amazing. I feel like you keep putting yourself down with these, but
well, I thing is I know what can be done and how they can look, and I'm a bit haphazard with it all. But I enjoy what I do. I'm not that much of a perfectionist. Enough of a perfectionist to be able to sort of take these sort of photographs. But I don't start fretting too much if they're not perfect.
I do honestly.
There's the bat.
Wow.
So it's just when you do the processing, you can just push more colors up. So this is part of the North America nebula called the Cygnus Wall, that bottom part. That's sort of supposed to be like California.
Oh.
Sort of, you see that's the other parts of North America. I've actually got, I think, yeah, there we go. So this is a composite, so a mosaic. So you can see the pelican up in the top right there.
Yeah.
And that in the same, so basically this, when all the pictures are joined together, they're really close together. So that's the North America nebula next to the Pelican nebula, and that's where they are in the sky. That's exactly how they look.
Oh, I do like the pelican with his little little star eyeball.
And also in the middle there, in fact, this is quite cool because I only found this out the other day. A lot of people think this looks like Deadpool.
Oh, it is! It is Deadpool!
That's quite cool, isn't it? With the red mask and the eyes.
And next to the pelican too, so easy to find.
Is the pelican's about to eat him?
No! No, it's just his head because Thanos cut his head off.
Oh, right, yeah.
I think it was Thanos. Can't remember. Doesn't matter that much.
He's had all sorts of body parts chopped off, hasn't he? This is very recent, so this was, I think, in February. This is the Iris Nebula, and this is one of my favourite photos. I think this came out really well. And again, the dark regions you can see are actually dust clouds, so they're blocking the light. It's not that there are no stars there, but the dark patches are actually light being blocked. If we zoom in a little bit,
it does look like an eye. I've seen a cat who has eyes that look exactly like that.
Yes.
So is that why it's called the iris?
I think so, yeah.
Yeah. Oh my God, what a stupid question. I retract my statement. I'm not confirm nor deny what I just said.
But yeah, I like that picture. That's cropped a little bit, so the bigger picture, the full picture was a bit bigger than that, but I just cropped out the middle bit because it's. See, there you go. That's the full picture and slightly different processing, so you can see all the nebulosity around it. And this is a reflection nebula, not an emission nebula. So this light is being reflected by that star in the middle. It's not being the light isn't being given off by the gas clouds. So yeah, it's quite a cool pic. That's a bad Wizard nebula. That was one I did recently that didn't go well. Too much light pollution, and that's a nice big bubble. So
That's so pretty.
yeah, it's just an expanding gas. It's expanding at thousands and thousands of meters per second. I think it's expanding by light years. It's so fast, almost.
Could I kind of? Oh, I've got the fear to say this now, but I'm like, it kind of looked like there was a little baby or a fetus in it.
In the middle of it.
Yeah.
Yeah, it does look like it could be a protective shell, doesn't it, for something?
Yeah.
Something
It's the two little stars that could be eyes.
Be a very big baby if it was. That's a better Pac-Man nebula. You can see a bit more detail in that.
Oh yeah.
Just go and you can see again. These are gas clouds. So what are called Bok globules. So I don't know why they're called Bok globules. Yeah, Bok BOK, but they block the light. So they're patches of dark cloud matter that block the light. Oops, there you go. So I've this is the picture we were talking about. So it's a bit well, I don't know, not a bit early really. We're getting on a bit, but this is using my new camera. So the one I unveiled earlier, the mono camera, which I used on Monday night. I only had an hour of time to play with it. And this is using, I was talking about earlier, what's called the Hubble palette. So instead of it being red, green and blue, traditional visible red, green and blue light, the three narrowband filters that I used get mapped to the red, green and blue, and this is what comes out. Now this isn't very well processed. In fact, I will show you some better pictures in a minute of where it's been processed properly, but it just does look quite cool. It's quite colourful.
It's amazing.
Yeah. Well, what it should look like. Well, this is a sort of more monochrome version of it. So you can see the pelican again, though. You can see its back and the beak. But this is a monochrome image of it. So you can see the detail is much more sort of when I put it in that, you can see the cloud, the black areas are much more defined. But the next two are the ones that have been done by a friend of mine. So this is what it should look like in a more natural color. So this is the HA spectrum. So you can see it's red because HA comes in the red spectrum, and then there's a black and white version, which I think is quite nice as well. But the prettiest by far is most definitely the first one.
Oh yeah,
even though it's not supposed to really look like that, and the filter wheel was off kilter, and I only had that is actually only 45 minutes of exposures.
It will always look like that in my heart now forever.
so yeah, it was a very quick session to just try and see if I could get everything working to a certain extent, which I did. I've got a lot of learning to do with the new monochrome camera, but that's my first proper monochrome image using the filter wheel, using the new camera. So yeah, and that's that color version is the first time it's been seen in public. So yeah, I will post it on Pip's Astrophotography channel.
Yes, please do. And it needs to be shared far and wide. It's absolutely gorgeous. When you first sent it to me, I actually did do a little squeal. Because I was like, oh my God.
Well, I didn't know what I was going to get. Yes, of course, for no reason. You can have a copy. I don't know how you want it, but I think I might have a PNG or something somewhere that might be better. Or whether this is properly processed, so that's probably a JPEG. But yeah, of course you can. I'll drop something into Discord, Pip's Discord, if you're not on there, or wherever you want. But yeah, anybody can sort of, if anybody, as long as people ask, I don't mind anybody having crack at my pictures. So yes, moving into the summer, it's going to be hopefully a little bit of planetary. I don't know yet. We'll see. and then back onto the nebulas in the autumn, because I want to do a full picture of what's it called, the Veil Nebula. And what I will do, I will show you, just because I'll show you. And this is why I'm about to sort of show you that why I don't think, why I know I'm not. Although I enjoy it, it's my hobby and I'm great at it. And as far as it goes, there are people that are way better. So if I go Veil Nebula, and let's complex, and I'll show
That
you.
means I'm gonna have to have you on again to show
Well,
more
quite
pictures,
possibly,
and it would just be picture times with Steve.
pretty much.
Yay!
Well, the thing is, I can only, you've seen most of them already, so let's go for
They're
that one.
so amazing.
Here's something. Here we go.
Oh wait, yeah, I forgot after.
No, I've just got to wait. Where is the picture? So there it is. Here's the image. Right, let me share my screen, and I'll show you the sort of thing that some people can do. Oh, that's the wrong window. I don't want that. And StreamYard. That'll be it when it's shared. Let's share my interweb screen.
Oh.
Yeah, that one. Yeah, there we go.
Micro says we moved past it a while ago, but it doesn't. Oh, sorry. Black and white's hard for me to read, so I'm struggling there.
I'm changing back, but doesn't the pillars of creation have spherical shapes in it, showing the creation of galaxies? I don't know, actually. It might well have. I know that it's got some beautiful details in there. It's star creation mostly, I think. I don't know about galaxies. Because it's a nebula, so it's a nebula in a own, so it wouldn't have galaxies forming it, but it will have stars forming in it, and that's why it's quite famous from the Hubble picture. You can see all the gas in there as well. Yeah, that's the thing. For no reason, what I'll have to do is I will have to probably convert it into a different pixel bit depth for you, and yeah, because I had some posters made of my stuff, so I'll try and convert it into a decent format so you can print it out. We'll sort that out, no worries. But if you can see, is that up on screen at the moment?
No, because it's our screen that you're showing.
Oh right, okay. I've just changed it. Oh right, okay. Let me move that out and go. Let's try.
I was waiting till it popped up the other one, but it's ours just now.
Stop sharing that then, and let me go to sharing. Let me do share a different screen. It should come up with it. Oh, God. There it is. That's better. I've popped it out.
By creation, it would be a galaxy once it starts cooling off. More and that word condensing. There we are.
Condensing. So that picture there. So if you look at that picture there, you can see at the bottom of it, you can see the Witch's Broom Nebula.
Oh.
And at the top of it, you can see the Bat Nebula with that other part, the NGC 6992. So that is the entire complex, and that's Pickering's Triangle there to the right. So that's the entire complex, and I would like to make a picture of the whole thing, make a mosaic like that. That would be a nice thing to do. I've been planning.
That would be so cool.
So yes, I got lots of things on my list of things to do, but with moving, that was I got to get that sorted first. Yeah, so then I'll have my nice southern view, and I'll have less light pollution. Yes, I'm looking forward to having my new place for sure. But yeah, I don't know what else to show you. I mean, we've had a look at all my pictures. I have got other. I've got loads of bits of kit, but none of it's really interesting. So mainly it's the telescopes and the maps. You have a question? Go on.
Yeah. I know. My end goal with a lot of my projects is there's normally like it's done. Would you say yours would be your pictures, and then that would be like you've completed that part of the hobby, and then you can take more pictures and that kind of?
Yeah, I don't know with this. It's a bit weird because there's always something different. I mean, I'm even with because of course I started taking the color pictures, and now I've started to take the mono pictures, and then I've got the mono narrowband. And then you can start to do mosaics, and then you could get a different telescope that gives wider fields, like I was talking about before, or another telescope that's got really, really narrow fields. The sort of top end telescopes are, this one is, it's what's called an 8-inch, so it's 200 millimeters. So the mirror at the bottom of it, so the mirror down the bottom of that tube is 200 millimeters across, which is 8 inches, give or take a little bit. But the biggest telescopes that amateurs use really are sort of around 16 inches. So they're twice that size at the bottom. But they're also a different type of telescope. What they have is they also have not just the mirror, but they have a lens at the front as well. So it's almost like a combination of the two, the refractor and a Newtonian telescope. And they call CSTs, or Cassegrain telescopes, Schmidt-Cassegrains. And they're for looking at really, really deep into, like tight into galaxies, and you get really good detail using those telescopes. But they're so big and heavy, you need a massive, great big heavy mount to put them on. So the telescope might cost you £6,000 or £7,000, but the mount will cost you about £5,000 to £7,000 as well. So you're starting to get into realms that just are out of my pocket. So I'm happy with what I've got at the moment. So yeah, if anything, I'll be going wider field in the future, because I love those big nebula complexes. So using a smaller telescope and a bigger camera, that may be the way to go.
That's good, because I mean, my main hobby at the moment is coloring in rocks. And now it sounds totally ridiculous, but I find it really therapeutic. And I've kind of found that once that the rock's done, I find a nice place to put it, and once it's where it should be, that's it. But I'm forever finding different colored pens and different paints, and trying to work out how to do glitter.
Rocks? Oh, you're changing the rocks, or new rocks?
The new just rocks, like actual rocks I find at the beach.
Yeah, but do you once you've done one, is that finished, or do you go back and change that one?
Oh no, that's it, done.
Right, okay. Yeah, because with the astrophotos, you can obviously, the taking of the photograph with all the equipment is only the first part of it. There's a whole set of skills and bits to do that, so a whole set of software and all the gadgets you need to do it, the telescope and the cameras. But once you've got those pictures, it's a whole different art to stack them all together and make the actual image itself. So you need to use the special software to stack them together, and then you need software to pull out the light and make it look nice. And you can get software that will, a lot of people use Photoshop and stuff like that, you know, the dreaded show Photoshop. But then it's all about how you know, it can be quite subjective about how you adjust the picture. And you saw there, I had several pictures that were the same picture that I just processed in a slightly different way to get different colors and stuff, so that you can always be playing with stuff after. But I don't generally tend to go back to data once I've created a picture, but I will soon. I think I've got so much to play with. You know, each one image that I take is around between 20 and 30 meg. So if I'm taking sort of 12-15 hours of photographs, it can build up quite a bit. You can end up with quite a lot of memory being used. I use I use GIMP as well, Dora, because I don't pay for Photoshop. I do use GIMP, and yes, I'm sure Slim would most definitely use GIMP instead of Photoshop.
Not for any particular reason at all.
No,
it's not the name or anything. Nope.
So yeah, it keeps me out of trouble, really. It stops me, you know, spending money on sex, drugs, and rock and roll, I suppose. But yes, it's a bit of a passion. Once you start, you can't be like Pringles. Once you start, you can't stop. It's always wanting a new bit of kit or whatever. Even like little things like that. I mean, what have I got in my magic pot?
Oh,
So,
there's a magic pot.
well, I've got lots of magic pots, but those are the
Oh,
filter
some more
boxes.
show.
So
A little warning, we may have to start wrapping up soon.
yeah, sure.
Just so you know.
Filters, nose pieces,
Oh.
extension tubes. See, there's all sorts of extra little bits that go to building a setup as well as the telescope itself. So
So you just
things
tweak,
tot up.
tweak.
Yeah, absolutely. Getting distances right and all that. There's so many little technical little bits and pieces to it, but I suppose that's why I love it. It's not an easy hobby to do. If it was easy, I think I'd be bored of it. And also, if it was always clear, I'd get bored of it as well. So it's quite nice having those cloudy periods where you can't take pictures because it makes you wait and want for the clear skies.
Yeah, I always like having something to look forward to. And then that kind of creates excitement, doesn't it? If you could do your hobby all day, every day, it's not fun. It's like I like to find the perfect rock. Now I have a perfect rock in my head. I know what I want to put on it. It just has to be just that right shape. And if it's not, I'm pretty disgruntled until I find it.
So you're still waiting to find that perfect rock?
I am. I've been trying to find the perfect rock to do a proper Scully face on it.
Scully face?
Yeah.
Okay.
I'll have to show you when it's done. It makes more sense.
I can't wait to see it. I'm sure it'll be lovely.
It's not as good as your
pictures. Well, I don't know. It's just different, isn't it?
Oh yeah, I suppose it is different.
Yeah. Yes, I've got a break over summer now. Really, I've got to because of the no astronomical darkness. I've got to be patient and wait for the planets in July. So yes, I won't get much chance over the coming weeks to do it, but that'll give me a chance to move and everything. So yes, I'll probably be packing all of this away pretty much, which will be a shame. I'll get twitchy. You see, I'll get twitchy in a few weeks' time, and I'll want to get it all out. So yes, I'll be ready when the time comes.
Well, I'm glad that you've got that.
As I say, yes, keeps me out of trouble. Thank goodness.
Thank goodness.
Yes, I could get into lots of trouble.
I could imagine.
I'm too old now. I'm too old for trouble.
Oh yeah, thank you, Brainless, for posting that link in the side chat. Because I can't remember specifically the time, but I'm sure Global Mom said it would be in about an hour. Slim show is, so I'll need to catch up on beverages before then.
Likewise, yes.
I'm saying because I've had a cup of tea for the wholesome corner.
I'm very wise too.
Oh, one last thing. Is there any extra questions in the side chat?
Yeah, anybody now, you're welcome, Little Wolf. That's no worries. I know it can be a bit dry and boring at times, but it's something I love. And yeah, I think as I'll go off on tangents and waffle about all sorts of stuff. So, but yeah, if anybody does, have any questions or want to ask about telescopes and shit, either hit me up on Pip's channel or find Astro Biscuit's YouTube channel and join his Discord.
And would you like me to link them down below if I can? Because I will have to figure out how to go.
No, don't worry about it. Don't worry about it. If people are that interested, they'll find me, won't they? Yeah, for no reason. I don't know whether you're on Pip's Discord for no reason, but I don't know whether you might want to link that. Ette, you've not got your Discord, have you? So
no.
But picture-wise, I've got a Flickr album and there's a video out there as well. But if there's any particular pictures people want to borrow or use or have, that's no worries. You're more than welcome.
I'm trying to figure out how to. Somebody who is more techie than me, please help! Please help! I'm not. I think you have answered all the questions.
Oh, well done, Brainless. Yeah, Astro Biscuit. Tina and
Thank you,
Brainless right in there.
Brainless.
But yeah, I think if you find on that, there should be a link to
Yeah.
the Discord on there as well. So,
Okay.
yeah, there are some very, very talented guys on the Discord channel who do stuff way better than me. And there are the youngsters who just use a mobile phone and a small telescope. So there's a bit wide range of people on there. But yes, if you want to catch me specifically, I am on Discord where you can get Ette can pass on my details.
I will, as long as you're comfortable.
Of course I am.
Okay. Do you have anything else to say? Anything else at all? Any shelling? Anything like that?
I don't think so. I think I've probably bored you all enough today by now.
No, everybody's amazed.
I've got some
Nobody's
Lego to go and
bored.
build.
Ooh.
I treated my
I would love to see pictures after.
well, I'll pop them onto Pips. But
Yeah.
my work gave me some Amazon vouchers, so I treated myself to some Lego to go in my new man cave when I move.
Awesome.
So yes, that's
See, Brainless Lego. See?
Yeah, absolutely. Yeah. And I'm not sure whether I want to open that one though, because that's a bit of a collectible. That one.
See.
Yes.
Everybody's loving your stories of astrophotography and beautiful
Oh dear,
pictures.
I've got some. Yes, I've had some cock-ups along the way, shall we say, for want of a better word. But yeah, it takes time to learn these things. But yeah, I do all right at it now. So as I say, I have fun with it. But yeah,
Some fish nebula.
Oh,
Is that what it was called?
The fish head.
The fish head nebulas.
Well, I might take some. I've done it on Pip before, but as the autumn comes in and some of the nebula become more visible, I'll try and get, once I've moved, I'll try and get the pillars of creation, and that'll be a target for you. So I'll try and you can let people know. You can show it on here on one of your streams or whatever, if I manage to get that. So
yep. Two closing things from my end before we say goodbye is Goldberg Mom says that's why you get two. You build one and keep one for a collectible.
Yeah, no, my wife doesn't let me do that. I haven't got enough room yet. Well, I'm moving to a house that's got more room, so maybe
maybe
I've got ideas.
Say pretty please, and then puppy eyes.
The ideas for my man cave are immense. I've got some really good ideas for a Lego Star Destroyer coming out of the corner of the ceiling.
Oh my god, yes!
Chasing the Tantive that I've got across my man cave ceiling. So yeah, we'll see. I've got to rebuild the entire shed complex first. But
oh goodness!
I'll maybe show you around one day once I've done it.
Oh, yeah, please do. And Slim is doing his stream, and there's been a couple of people who sent links out to that. So have a little nip, have a little look-see, and join. Well, I'm going to be there as well, and I know there's going to be some other lovely people there too. Let me see. Yes. Purple. Sorry. Now I'm getting distracted. I'm trying to wrap up, and I'm like, combine the hobbies, build a
Lego. I'm sure it's probably been done. Well, I think something that has been done is to build a motor focuser, which attaches onto the focuser. I think that's been done before, but yeah, an entire telescope. I've possibly.
Oh, and Sarah Little Wolf says I have to draw the galaxy on a rock.
Yeah, absolutely.
My best to do that.
Copy a picture.
Right. I'm gonna wrap up now before we keep getting distracted, so that we can all have a little rest before Slim's stream for those who are gonna go there, because it's been a stream marathon kind of day.
Yeah, filled the 1.5 hours though. So.
You've done that, and we've had so much fun.
Well, thank you for having me. It's been fun.
Thank you. So Thank you, everybody, for watching.
Yay.
Yay! Thank you, Chiosa, for making this for me. And stay safe, look after yourselves, and all them lovely stuff. See us again next week where we have another special guest. Bye-bye.
Bye.